Okay, in example 3, there's two parts, and they're basically just more practice using the shortcut derivatives. We do get into a little bit of interpretation in part B, and then the other thing that's new in this problem is the powers of x that we see are a little more complicated than in the previous two parts. Okay, so for part A, I think before you start taking the derivative, you should always rewrite if you have a function like this, you should rewrite part of it using powers of x, or rewrite all of it if you have to, but only one part needs to be rewritten here. So f of x I can write as 7x cubed, and then the interesting part is, of course, the x cubed on the bottom of that fraction. So what you should remember is if it's on the bottom of a fraction, that's a negative power. So this is negative 7x to the negative 3 plus 7 still. And let me warn you, when you do this, a lot of times students somehow, part of their brain thinks, oh, I've done it. I've rewritten it and I'm done. But that's not the derivative. That's just basic algebra and what the definition of a negative power is. So I haven't done the derivative yet, just to emphasize. I will do it now. So f prime of x, and the rule that we will apply is the same one that we've been practicing. The power comes down in front, and then we subtract 1. And that applies to both powers. So we'll do it for the x cubed and for the x to the negative 3. So this is 7 times 3, x to the 2, because we subtract 1, minus 7 times negative 3, x, and if you're at all uncertain about what happens here, just write it out with another step. So negative 3 minus 1, and then plus 0 at the end. So that negative 3 minus 1 is another source of very common mistake, where people don't subtract correctly, and maybe they think that it becomes negative 2. And so that's why I said to write it out. Negative 3 is its own number, minus 1 is its own operation, and then we combine them hopefully correctly. If I clean this up, I get 21x squared plus 21x to the negative 4. And I'll just stop there. Okay. Part B is pretty similar. There's one more, difference in this part because it's an interpretation. So first of all, let me say that before we were doing marginal cost problems where our first definition of marginal cost was it's the change in total cost when you increase production by 1. And that's the right definition. But in the case that it was a linear function, that ends up being the same as the slope. That's how much the total cost would change. And if it's a curving function or a general function, from now on, what we do is we interpret marginal cost to mean the derivative. So it's the derivative of the total cost function. Okay, so let me rewrite this function 165, and I should rewrite square root of q, I should rewrite that as a power. So this is q to the 1/2. It's a power of q, meaning a power on top of q. And then let's see, plus 100. So that's total cost. And then the marginal cost is equal to the derivative of the total cost function. And so I should be looking at my usual derivative rules, the same rules as before. The 1/2 should come down in front, and then I should subtract 1 from 1/2. So this is 165 times 1/2. And again, if you're at all confused about the subtracting, just write it out right on top of that fraction, or on top of that q. So 1/2 minus 1, and then again plus 0 at the end. I will clean this up a little bit. Let's see, this is 82.5 when you multiply 165.5, q to the negative 1/2. So that's the derivative. If you look at the original problem, it says find the marginal cost at q equals 5. So you should always, when you have a problem like this, do the derivative first and then plug in the 5. If you do it in the other order, it won't come out right. So we've done the derivative, and now we should do c prime of 5, which means plug in 5. And this is 82.5, 5 to the negative 1/2. Now I can clean this up a little bit. Again, I can calculate it. This is 82.5 over the square root of 5. And this comes out to be, I think, 36.9. And again, if we want units, this should be dollars per item, I guess, is the most general way to describe that. Okay, so the only thing new there, like I said, was the powers that we had to rewrite a little bit, and then the interpretation of marginal cost.